everybody's at, but we won't tarry too long waiting on folks. One of the things that I need to announce this morning is this is one of those things that it's just a couple of people probably causing grief for everybody, but because of some things that have been found by the cleaning staff, we're going to have to cut out food and drink in these rooms, period. So this is the last day. I'm not going to make anybody, this ain't the airport, we're not going to pour it out before we get on the plane, but after today, we'll have to confine that to break times only. Sorry, again, rules get made because a few people can't follow them, not because everybody does.
Not like everybody has
Really hurt my coffee.
I know, tell it. Secondly, there are still openings in the fiber forming and chemical operations, and I say that not to push anybody towards it, but just because we do still have openings, and we are going to allow people to go into those professions for the near future anyway. So again, I'm not pushing, I'm just announcing what is. So if you're comfortable here, glad to have you. If you have thought about maybe I should have or whatever, there's still opportunities. So again, not asking, pushing, or identifying anyone for that particular move, just making the announcement that there are opportunities still there if anyone is interested. So, and that's all I got to say about that.
Are we still allowed to eat some chocolates in the room?
Still allowed to use what?
A lolly, chocolates?
What kind of chocolate?
New Zealand.
No food. So. Right now, if it's water with a cap, I'm gonna try to, because I'm gonna have to have something to wet my whistle. I prefer sweet tea, but I'm gonna remain with water. So.
Is that okay?
As long as I don't see it, and we don't see it on the floor. So bottom line, be stealthy and be clean, and you won't have anything said to you.
What about this? I'm not being smart when I say it. Is that okay?
I'm not gonna say anything about it.
Thank
I might call you Kojak every once in a while, but
you. Call me
No,
what?
that'd be Josh.
Call me what?
might call you Kojak.
Kojak. Oh, yeah. Not too many people remember him.
I just dated myself just then.
Well, you could have said Perry Mason.
That's true too.
All right,
That one on the tag.
we're gonna get started, and every opportunity that I have to open the simulator and kind of relate some of these components to things found there, I'm gonna do that. Not everything is on that simulator. There are a lot of components that go into motor controls. Now, this course teaches you not only what the components do, but sometimes the inner workings of how that's accomplished. Now, again, that's not important. I don't know as much about the inner workings as I do what the component does, and that's just by the nature of, to change out a contactor, I don't need to know how every coil is wrapped and the difference of the innards, but I do need to understand the pinouts and what each pieces are and what the terminology and nomenclature is on the item, so that I'm replacing it with a similar component, if not an identical component out there. So we may hit some things where I say, I don't know, let's Google that, or I don't know, let me look at the book, or that goes beyond what we need to know to get through. Because again, you guys are getting 2 years worth of stuff in 1 year. So there's a lot of detail in this book. And bottom line, change a starter out on an automobile. I need to know how to turn a wrench. I need to know how to go through each step. I need to know how to tighten it, tension it. But I don't necessarily need to know how the starter itself works. And it's good if I do. I'm not saying that's a bad thing. But to do that, I don't necessarily need to know the inner windings and everything on the starter. So, but I will say this, if it's on these slides, you're very likely to see it in a test. So with that said, we're trying to pick out the low-hanging fruit of everything here, because this book is 66 chapters, I believe. And I know some of you weren't here. I won't mention any names, 65 chapters. But some of you weren't here, but some of your counterparts, and again, I'm not saying that one should look for PDF copies of books online, but some of your counterparts found this book online. So if you need a reference, they may know where to find it.
Will you be able to imprint it for us?
Not print here anyway. Because your instructor is not condoning the downloading of books. Let me say that 100% adamantly.
Mr. Radley, this that's on the slides is the 7th edition, and that's the 6th edition.
That's fine.
Okay.
Typically what happens is they change pictures, they change a little verbiage, sometimes they change chapter order.
Okay.
Outside of that, it's almost identical. It's just a way of going, there's too many copies of this $300 book, so we're fixing to create a $350 7th edition.
For the link?
What?
Sorry?
I said what they usually do is they'll say the 6th edition, there's too many used copies floating around, so they'll create a 7th edition so that everybody has to buy new books. That's how the book manufacturers make money here in America.
Because of its price.
Yeah.
And how much do you get for the link?
How much you get what?
You have a link to the PDF.
I have
How much do you
no
want
link.
for that?
I have heard rumors from students that there is this link out there that you might could get to, but again.
I had a book one time that was like $700 new.
That's outrageous.
Yeah.
But again, I am not condoning that, but anyway, enough said about that. Again, I know you just walked in, two items here to cover real quick. No food or drink after today. We've had some complaints from cleaning staff. So we're not like the airport, we're gonna make a report out today, but tomorrow we'll have to begin. Also, there are still openings in fire performing and chemical. If anybody's interested, I'm not pushing anybody in that direction. I'm just making you aware of what is. All right. So for this chapter, we're going to state what motor control is, and really it's wide, it's varied. You can see, and when we say motor control, a lot of the same components that go into control of motors, or some of the same components, are also the components you saw in the light simulator. It's relays, it's switches, and so forth and so on. So you'll see some similar components that, even though I'm saying motor controls, you can go back to that light circuit, and some of these things will be found even in something as simple as that. We're going to discuss the difference between manual and automatic. What do you think would be some differences between manual and automatic motor control?
Manual would be actually pushing it with a physical body, automatic to be controlled from several different locations.
Yeah, that's typically correct. Manual means we have to have some sort of physical interaction with the equipment. Automatic means there's some type of control out there that's built in, some logic that dictates when this piece of equipment turns on or off. And we're going to discuss some considerations when installing motors or control equipment. And we're going to look at a control system, and we're also going to talk a little bit about surge protection. Just to give you an idea of why surge protection is so important. When your refrigerator, your air conditioner, washing machine, dryer, sometimes when certain parts of that cut on, what happens when you're sitting in your house?
Power flippers.
Lights will flicker.
Yeah, you'll see lights dim down. And that's a surge, or actually a drop, but also Georgia Power occasionally will kick out a surge, a high instead of a low. But either way, it's still a drop or a sudden peak in power. Typically, you see more drops than you do peaks. But a lot of control equipment, it does not appreciate that one bit and have to have some type of surge protection. That usually comes in the form of some sort of universal power supply. We had a piece of equipment at Rockwood that's called a router, and it was just like a router you would cut wood with, except it was designed to cut fiberglass, and it used bits very similar to a Dremel tool. And it cut from underneath, and what we do is, we had some boards that weren't much bigger than that, so we put 12 or 15 of those on a panel, and they would be, you know, in order to process these things, they had to be fairly sturdy, because we're shooting parts, literally popping parts on top of this board with this piece of equipment, and parts would go on both sides. And then, when it came time to take that panel down to the individual boards that were on there, so that they could be covered and sold, we would actually cut with a router underneath them. And what this did was just, it cut strips of that fiberglass and cut it out into what the final board would look like. Bless you. And that way it would be ready to go and cover. So you have to be pretty precise, because some of these covers were very form-fitting covers, and if you routed a little to the left or routed a little to the right, it wouldn't fit the cover properly, and you just scrapped what was then a finished assembly. And the other thing that would happen sometimes is operators would load the wrong program, and they would cut boards up, and because this process was semi-automated, boards would go into the router. They might be over here chatting with a friend, and by the time it's all said and done, we've scrapped a few $1,000s worth of product before somebody noticed, hey, we're cutting straight through the middle of boards. So we had that happen, so we implemented this little system where it would read the barcode of the board, load the proper program. Well, we still had boards getting routed wrong. So we started writing operators up, because there's a way to manually bypass that router barcode reader and manually load the program, because we just assumed, and it always seemed to happen fairly early on, but that ended up being a coincidence. What was happening was, right in the middle of running a board, sometimes a surge would hit, the router would just totally lose its XY coordinates, and it would just start from where it thought it had left off, which would sometimes be right in the middle of the board. And it took Georgia Power coming out and putting this piece of equipment on our line to find when and what was causing the spike. So surge suppression is very much a valid part of, especially if you're talking any kind of precision. I don't know if you'll see much of that when you're talking about just powering an oven on and things like that. I don't know what they have that would be critical enough, but I'm sure there would be some control systems that could very well. I mean, a furnace is not going to jump from 2,000 to 3,000 degrees like that. I mean, they've already told us it takes 30 days from this thing just to warm up to temperature. So you know, a quick spike that suddenly turned the heaters on and then turned them right back off, probably not a big deal, but I don't know what they have that could have that, but I'm sure it had something. And motor control can mean anything from just turning a switch on and off to a complex system intended to control several motors. And if you look inside of your simulator, you'll see several different things going on in there. And there are, let's see, we've got the pump motors, we've got the agitator motors, we've got the intake two motors. So we've got our share of things on that simulator that go into this. So here we have just a very simple motor. Right here we've got our neutral line coming into our motor, L1 going through a circuit breaker, feeding a switch, feeding the hot side of that motor. And again, convention tells us we want to break the hot side. So that's why you see the circuit breaker is part of the path, and the switch is part of the hot side path. So if this breaker is connected to L1, 120 volts, this side's connected to neutral, we have that breaker on and we turn on that switch, close that switch, what should happen?
Motor should come on.
I'll switch and change my recommendation. Maybe some of you did need to go to fire. No, I'm just kidding. Y'all have to wake up too. That's all right. I saw a thing on Facebook this morning that said 108-year-old windows. And I actually had to think for a minute, did they mean they had a quantity of 108 windows that were a year old, or did they have some windows that were 108 years old? Inquiring minds, woman. So, that is a simple, but it's still motor control. We are controlling whether that motor is on or off. We're using a knife switch, which, by the way, isn't the most safe switch to use, but especially early in the century, that was a pretty common method. You've seen it on the old Frankenstein movies, we've gotten a little more advanced. Several factors. Let me go back to something here. The size of the conductor and circuit breaker are determined using the National Electric Code. This motor is going to have a amperage rating. So if that motor is going to have a 27 amp rating, what size breaker or fuse do you think we should use?
30 amp.
Probably 30 amp. That's probably the closest size. Now, sometimes there are some cases for oversizing that breaker a certain amount. Might even get into a 35 or a 40 amp, just depending. And there's all tables and everything set out there for it, just simply because if it bound for a moment and pulled, if we went 30 amp, it bound for a moment, pulled 32 amps during some kind of process, we wouldn't want necessarily tripping the breaker out. But there's tables, there's guides, there's online web helps. But bottom line, that breaker needs to be somewhere in the neighborhood of the amperage rating of that motor, the operating amperage. These wires need to be rated at high enough current that the breaker or fuse will always trip before the wires begin to burn. And that's pretty much the thing. So we can use 100 amp wire here, but we've still got to maintain that breaker at or near the operating amperage of the motor. So we can go up wire size if we've got bigger wire on the truck, because it's just going to handle more current, because the fuse is to protect the wiring and to protect the motor. But we've still got to, even if we put 100 amp wire on it, we've still got to rate that fuse by the NEC's ranking based on that motor current. So we go up a wire size, don't go up a breaker size too. What is the convention for neutral as far as the NEC is concerned?
What do you mean?
Neutral.
White?
White or?
Green.
No,
Oh,
that's
we use
brown.
brown, she just said neutral.
Blue?
Nope. Well, you might be getting to, I think
I'm
you're
going
getting into the
international.
international code
Yeah.
now.
Great.
Nope.
It's black.
It's close to white.
Black is
Black
or
gray.
It's gray. The reason for that, dirty and aged white wires look gray. So white or gray is the convention for neutral. All right. What does the NEC? Okay, let's go to ground first. What are our colors for ground?
Green and strip,
Black.
bare.
No.
Black.
No.
Green.
Bear. Green and yellow is international, and you'll see that a lot. Green and yellow is international. Green, yellow, or bare for ground.
And what's bigger?
Strip
That's
copper.
right.
Copper wire.
So you know insulation.
All it's got is
pure
epoxy
copper
on it.
wire. What does, now I'm not asking what NEC says, what is convention for L1 in the US? What is convention? Black. L2 is typically red. When we get into 240, we'll see black and red. What does the NEC say as far as any hot conductor?
Black.
Anything but
White or gray?
white, gray, green, yellow, or bare. You can have purple, you can have orange, you can have any color of the rainbow except the ones we just talked about. But there are conventions. If you look in the NEC, it'll clearly state that. But typically on 240 volt systems, you're gonna see black and red. Typically, but not always. And then if you,
In the residential world, you're gonna see black and white.
Yep.
Both hot.
yeah,
Mm-hmm.
that's exactly right.
240 volts, right?
And On larger pools inside of a, even on three-phase stuff, you'll oftentimes see all black wire with colored tape on the end of it, NEC allows that. So, it helps you identify the legs without having to purchase higher dollar, large wiring.
You talking like just colored tape such as colored electrical tape?
Yeah.
And it's usually right where it gets terminated inside the box, just a few inches above where it's terminated, you'll have a wind of colored tape. And most authorities have a jurisdiction to set that. I won't say all of them, but most.
That just doesn't seem safe.
Because what happens if that
Tape
wire,
comes off.
yeah.
It's one of the few things that.
When that, actually it was Hamilton ITS, that, machine shop I worked in.
Yeah.
The dude, he made automated equipment. That was his bread and butter before he went to
Yeah.
just straight fabrication. He, that's what he did. He put colored tape on the end of his wires. Now, a lot of times, 90% of the time, it would be the exact same color as that wire, but he made sure.
So you'll see different things, but know your equipment and don't make assumptions based on colors or wires. Know what you're looking at. So if you do see something that looks, we pulled the cover off here one time and Reagan showed me, and there was three-phase going in. You know what color the wires were on the three phases?
Black, white, red.
Green, green, and green.
That's even worse.
Sure as I'm sitting there.
Somebody ran out of everything else.
Obviously. All right, so several factors should be considered, the type of motor, the type of machine, the controls. Some machines have the motor control equipment pre-mounted on the machine, others require it separately mounted, connected by belts, gears, or chains. So it just depends on the application and what you're trying to do as to whether it's gonna kind of be all in one or whether it's gonna be a way. Power source considerations. Is it single phase? Is it three phase? How much horsepower, how much inrush, and that inrush is kind of that surge that it needs. The capability of existing power source and the availability of power. One of the things, especially when you're bringing in a new piece of equipment, when we were bringing in equipment at Rockwell that was replacing something that was old or we're building a new cell, we had a pre-formed checklist that had all these things down, and we had to go through each item by item, because when you're ready to get running, you don't want surprises. You don't want to find out this is not ready or this is not ready. And one of the things we found out later on that we didn't have on our list, and nobody noticed it until the day before, was we had a piece of really tall equipment coming in. Had all the power, had all the air, had everything you can need, had it all prepped out, had all the stuff laying out there, already had the conduit run, waiting on a piece of equipment. Somebody said, how tall is this thing? 22 feet. Our roll-up door is only 15. So Dublin Construction showed up that afternoon, knocked some cement out, and a few weeks later, we had a really tall door put there, but just to get this piece of equipment in the building, had a tall enough door. So just go to show you can't think of everything. You can best lay a plan. Sometimes you end up with some last minute hurdles. And for us, it was a door. Motor connections, considerations, horsepower, service factor, voltage, temperature rise, full load current rating, NEMA code letter. Again, we'll get into some of those as we go along. What type of motor is it? Is it a direct drive? Is it a machine that employs gears? Machines that require a long starting period? Squirrel cage motors controlled by variable frequency drives or direct current motors. And again, we're going to drill down onto a lot of these. I know I'm throwing boom, 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 but this is just kind of a high-level overview of what you're fixing to get into. We're going to start drilling. But all of these are used to power many of the machines throughout industry. Controller type. Motor starters are divided into two classifications. NEMA, which you see mostly here in the U.S., which is the National Electrical Manufacturers Association, or IEC, which is the International Electrotechnical Commission. So we're still in the United States, we're still stubborn, we're still going to have our own thing. We hadn't got on board with the IEC side of things. We'll allow the stuff in here, but as far as the U.S., we're still have our own separate, that's why we're not on the metric system, because we're smarter than everybody else in the world.
May I ask?
Sure.
But at Valmir, anyway, they will bring their own equipment, so they will be at the EIES?
I would imagine you'll see a
or
lot of
the
the
beer
IAC,
company?
mostly international. It's probably gonna be, by and large, European equipment.
So we're probably gonna have to learn both.
Yeah, you'll see both. EIC,
Okay, I thought you said EI, yes.
Maybe they will apply the IEC.
Aluminum.
I got you, I just misunderstood.
Consider the environment in which the motor and control system operate. How many of you ever been in a brake foundry?
In a what?
Brake foundry where we make auto brakes? I went to one up in mid-Georgia somewhere, I can't remember what town it was a small one. But this place, the very nature of their product, from tip to toe of this plant was covered in carbon dust. You know what happens to your wheels after time that you have to clean? That was everywhere in that factory. So think about controls. What is carbon good for?
Dielectric.
Fuels,
I'm dating myself again here, but how many of you remember years ago points in automobile? What's a trick you could do to somebody's automobile points? You could actually take a pencil and go over the points, and the points would fire. Carbon is a great insulator. So carbon dust is a floating, moving insulation through the air. So imagine what that would do through to control systems everywhere. So they had to have special sealed control containers, and even then, even in the quote-unquote sealed, he opened one up that had some of our product. That's why we were visiting the plant. It had some of our controls in it, and there was about a ½ inch of carbon dust inside of this quote-unquote sealed container. He said we have to vacuum them out every month.
I bet that makes it's like overheat really easily.
It doesn't help, and especially if you got fans, the very nature of those, I imagine they had to have some kind of special filtration, around that kind of stuff. Most of what we saw were just stagnant cabinets that didn't need cooling. But yeah, it's quite a, but here's what's so funny, and this was one of the things that struck me, that I'll remember till my grave. Well, our QA department was with us, and they would get real ticky, like our card extractors on our, most of our product were made out of a hard type of plastic. And sometimes we'd see some of those with a little gray miscoloring in it, and they'd flag them for that. And of course, scratches on covers, I was a little ambivalent about, because most of these products stack inside a rack, and all you see is the front, you don't see the sides. And somebody said, well, not the QA guy, but somebody said, if there's a scratch on the side of a brand new module, what are you gonna do? And this was one of the nastiest environments. He said, I'm gonna send it back. If I got a scratch module, I'm gonna brand new. I'm like, so, guess I'll never be able to talk about that anymore. But yeah, you should consider the environment, consider the housing. Is it hazardous areas? If you've got contacts at ARC, and you've got a place like Dixie Crystals down there in Savannah, you got to make sure you got the proper housing or got it enough distance away, because airborne sugar particles are flammable, and you don't want to control closing, creating an arc. And they had one a little while back. I'm not sure what exactly it caused.
That's what happened to the wood mill, or that chip mill in Hazelburg.
Yeah. So,
Is it in Savannah?
yeah. It's on the left just as you're going in there. They call it isn't Dixie Crystals anymore. It's
My cousin works there, and I can't remember the
Okay.
name of it, or his son does.
You ever seen that natural gas facility down there?
yes.
Yeah.
I mean, from a distance, not.
I went through that canal a few years ago fishing, and they were bringing a tanker in.
Yeah.
They had Hummers coming down the banks, and the skiffs with like guns on them coming down there with it.
That's
I
good.
mean,
That would be Well, that blew about half of Georgia off in that place went up.
They had a fire down there a little while back.
To
Really?
protect anything that might be
Seems like they
contagious.
did. I'm trying to remember exactly what
Just
happened.
bring them in,
It's
natural
kind
gas,
of
and put in a huge
strange
tank.
looking. See, I'll have to go back and look, maybe I'm dreaming. that.
Kyle Duffer, I think's what you're thinking of. There's a tank farm down there. I was down there when it happened.
What's the name of it?
Hal Duffer, well, not the sewer plant, Hal Duffer was
Okay,
a
I'm trying to.
tank farm down from the natural gas place that blew up.
But yeah, obviously there's hazardous areas, so, you know, don't just know your area, know what you're putting in, know the reasons. I don't know anything at Valmera. That was a very clean plant that we visited in Latvia. I mean, super, super clean everywhere we went. The building was aged, some of the equipment was aged, but as far as the cleanliness.
Sweetener Solutions.
Sweetener Solution. It's Crystals, just has a better ring to it, but
Yeah,
I don't know if I remember Sweetener Solutions or not, but I'll try.
that's why I said I
Lee,
couldn't.
speaking of Valmera, this question's kind of in the back of my head. We're making fiberglass, fiberform. Is there gonna be like any type of special equipment you're gonna have to wear, such as clothing or respirators?
Probably working around the furnace, yes, definitely. We didn't see anybody with that kind of equipment on. I went within feet of one of the outer walls and it was warm, uncomfortably warm, not unbearable warm, but uncomfortable warm.
Like Georgia summer?
Hmm?
Like Georgia summer?
Like Georgia
Georgia
Summer.
Summer.
Like Georgia, so yeah, just like Georgia, except there was no humidity. But lots of heat, yes, very much like Georgia summer.
I know at the Valmere plant now, they have to have the humidity.
Nice.
Will there have to be humidity pumped in there?
Could be, especially during the dry parts of the winter time.
That's
Now, in the summertime, probably not.
There's
on the
never,
fiberform.
it never gets dry.
That's one of the reasons why the South, as far as manufacturing of electronics, is a good place, because ESD is not as big a factor down here, because humidity does bleed that. If you notice, the only time we touch a doorknob and get zapped is about 2 or 3 months out of the year. So,
I touched the outside of my truck driving down the road with the window down it, a couple weeks ago. It just shocked the crap out of me. While the truck was running, going down the road, it scared me so, I thought something that grounded and shocked me to the truck. It wouldn't do it but once though, so.
yeah, normally once you dissipate it. And that's one of the things, ladies, especially guys that are guilty of it too, but y'all wear a lot more, less cotton than we do. But most of these gas fires that are started at gas stations, do you know why?
Static
Electricity.
electricity.
Women tend to, by and large, when they pump gas in the wintertime, they'll start the pump, get back in their car, come back out, and that's why it's good to touch the top of your car or the side of your car. Well, the sliding of the two fabrics across that seat, grab that gas pump handle that's grounded, got a nice little spark, got fumes coming out of the gas tank, and
It arcs into that hairspray.
So-
and
Oh,
it's
don't
all
say that. But, that's one of the reasons. Yeah, corrosive materials, obviously the cabinets have to be prepared if you've got that around, and of course extreme temperatures too. A lot of equipment generates heat, and there has to be some sort of ventilation, so didn't see a lot of equipment mounted on the furnace wall. So just wouldn't be real smart. These are some general purpose NEMA enclosures. What you see here is start buttons and stop buttons. This is an explosion proof, and you see the start, stops, just a simple toggle switch, but it's obviously for an area where a general purpose control wouldn't suffice, so it's got to be something a little more robust than what you see on the left
What
hand
does it mean
side.
explosion for?
Huh?
What does it mean explosion?
It's supposed to withstand an explosion, which makes you wonder who's gonna go turn it off after it explodes.
Like, that's what I'm getting, like,
Well,
what's the point of it
actually,
being
it's,
explosion
actually,
for?
it's supposed to be to where you're arcing and sealed inside of that container, so that if you're in an explosive environment, it will not cause the explosion.
Yeah. So,
May I
So,
ask,
yeah, I figure there's a lot more important stuff you don't want exploding than the,
control.
little,
is this explosion proof? To be safe after something is exploded close by, or something which will explode inside?
That's what he was saying. It's supposed to contain any arcing, is seriously what it's for. So
There was a lot
there's
in-
nothing that will hit externally. So if you were operating in an area that gas could occasionally vent out to, you wouldn't want this, when you flip the switch, to have it arc and create a flash. This is supposed to contain any arcing inside of the device itself rather than exposing. So,
The only place I've really seen those is where they refill the propane tanks.
yeah, that's a good place
Turn the
for it.
motor on.
A really good place.
This is change the subject a little bit, but I had to fire an employee, because he didn't have his, explosion-proof enclosure. He was out there changing a propane tank only for the smoking a cigarette.
Oh, duh.
Hold up. Similar thing out there at Evans Cabinets. I'm sitting there on the grinder about 40 feet away from our propane tank. The guy who was supplying our propane and refilling the tank was sitting there smoking a cigarette while he was doing it. I'm sitting there going, dude, really?
And-
I had
He's
that.
like, I ain't worried about been doing it for 30 years.
I'm fastly walking away.
Yeah, I had to go out at the probation office, I had to go out there and watch them as they fill the tank. He's got this big tanker out there filling our propane tanks.
Yep.
And he goes to light a cigarette, I said, dude, I know you're not fixing to. He said, oh, it's safe, I said, I'll come back when you through, I'm not
Was it
staying.
an old guy? It might be the same guy I'm thinking of.
We had a
I think I know.
transformer go out one time at Rockville, and the guy crossed the
Uh-huh.
phases on it. when he was
Same
putting it
guy.
in. And I was inside the plant, it sounded like somebody had fired off about 12 20-gauge shotguns at the same time, or, it was loud. And I imagine what would have been like when, in the heat. They said, Van said all he saw, he said he was behind it, Van Savage, said all he saw was just a blur of this guy running away from it. And he said he wasn't sure if the guy had actually got injured in the arcing and everything. But he said he walked over there to the Georgia Power van and said the guy was sitting in the back of the truck smoking a cigarette.
Well,
I can only imagine.
the same propane company at the probation office couldn't get our pilot lights to light for the heater. Okay, natural gas, the guy was supposed to let it bleed for like an hour. Oh no, he didn't. Big explosion. Boom! It literally rocked the walls of
Oh,
the
wow.
whole place. And I'm like, bet you won't smoke a cigarette again around it. He just looked at me and said, and turned around and walked off. And I mean, it literally, it wasn't the older guy that done it, it was a young guy, but he told him to go ahead and light it. But it was
It was
natural
the sign.
gas and it just, it blew sheetrock 3 floors up off the walls.
Mm. Also, codes and standards, OSHA regulations, UL, NEC, NEMA, IEC, it all depends. So everything has different ones. And a lot of this, you know, sometimes within the plant, you're under your own, I mean, you still have to comply, but as far as, especially if you're going out work, doing work for the public, you need to comply with what the local authority has to say in regards. And like I say, if the local authority tells you all your hot wires have got to be purple, and he's the one that ends up inspecting it, you won't probably hear that. I'm just saying that they're the ones. The NEC in the US is a suggestion. The local authority typically aligns with that NEC, but they can have their own practices and ways of doing things. It's just like the ground rods. Recently installed a pole at my house, and the Excelsior showed just a single ground rod. Georgia Power saying 2 ground rods. I went ahead and put a second ground rod simply because I didn't want to get rejected if he came out there. Well, when the guy did come out, he said, "I see you got 2 ground rods." He said, "We don't require that. It's fine."
Do you know what the European equal is to our OSHA standards by any chance?
I think it may all be under IEC, but I'm not sure. There may be, and probably, I imagine that Europe has some kind of combined just because of the interaction rather than, you know, because of all those countries, but I don't know. They're a lot more relaxed than ours, I think, by and large. Or I won't say relaxed, they're a lot more sensible than many of ours, from what I'm saying.
Why would we allow, I mean, different standards over here? That doesn't make any sense, us like manufacturing a gun that fires a surprise out of the back.
It's just the way we've done business, throughout the US. It comes down to the local, authority. Right, wrong, or indifferent. It's just like, we did a project here in Dublin, for the park out here, and the guy sold me a mini box, and I didn't notice till after we had it mounted to the pole, but anyway, I only had 8 breaker slots in it, so I had to go with the mini breakers to be able to get 16, and we needed 16 breakers, and the mini breakers are fine. But the problem was, when I went to land my neutrals and my grounds, there's only 16 lands, or 17, I think there's one bond, the main one. So I didn't have enough to bring in all my neutrals and grounds, so I talked to our local guy, and he said, I said, you know, what do you want me to do here? And he said, I said, I thought about going in and adding another ground bar at the bottom and just landing neutrals this way, landing grounds here. He said, that's fine. So I went to the local electrical place that shall remain nameless, that's near Walmart, and tried to purchase this ground bar. And he said, if you put that in, it's going to violate your NEMA cabinet. I said, okay. I said, but the local inspector that's going to inspect this before we turn power on said do it. Well, I don't want to say that. That's going to violate your NEMA cabinet.
What is NEMA?
It's the standard for the cabinet. Basically, if you drill in that cabinet, you just change the state of the cabinet, is what he was saying. I said, well, that's well and fine, but the dude that's going to inspect this and ultimately tell me to turn power on is saying put it in there. Well, I don't want you. I said, I don't want you to modify the cabinet. I said, well, let's just forget we had this conversation. I need a ground bar.
I'm gonna use it to beat you with.
Yeah, I'm gonna hang it from my car and look really cool going down the road. But he finally sold it.
OSHA standards, could they change from state to state also?
No, typically OSHA's very fixed. Now OSHA standards change within its own organization, and that's part of the problem with OSHA. And in fact, that's one of the things Trump ran on, right, wrong, or different. I'm not condoning Trump to anybody. I have my own personal opinion. But he said for every regulation we add, 2 have got to come off the books. So bottom line, we have just regulated ourselves into a corner. And that's been through multiple presidencies. I'm not talking about any one in that regard, but we have so many regulations. Just like, perfect example, in Latvia, I told you guys this before, you know, if we got guys on our highways, you know, 2 miles back, we're gonna have barrels, we're gonna have merge signs, we're gonna have flashing signs, we're gonna do everything we can to protect our highway workers, and I'm not saying that's bad. In Latvia, there were 2 guys out there painting lines on the street, no barrels, no signs, orange vest or yellow vest, I can't remember. And we asked Ilza about it, and she says, yes, our job is not to hit them.
Here's your sign.
But again, probably every one of those barrels and signs and everything else in the U.S. is required. Whereas over there, they teach people, hey, don't be stupid and hit people in yellow and orange vests.
Over here, you hit them and then sue the company for not having the barrels.
That's right.
Yep.
All right, so let's talk about the different types.
Lawyers and accountants run this country.
Manual, operator must go to controller to make any changes, to initiate any changes. Semi-automatic may use push buttons, limit switches to control the operation. And automatic is very similar to automatic. Semi-automatic, the operator does not have to initiate actions and controls after control conditions are set. All right, let's start over. Automatic is similar to semi-automatic. The operator does not have to initiate actions after control conditions are set. So basically, on the automatic, you press on. There may be some interaction between the operator on the semi-automatic. Once the process starts, they have to initiate something, and then after that, it works on its own. So there's just some differences there. All right, fuses and circuit breakers are for circuit protection. Overload relays are protect the motor. These are overload relays. One type of overload relay that you see is a thermal. And it's just like what's in your thermostat in the same theory. When the heat is when the heat is really high, the 2 pieces separate, turning the power off to the motor. After it cools down, they'll meld back together, push back together to form a circuit. Some are magnetic, some are electronic. It just depends upon the kind you've got. But the overload relays are to protect the motor and to protect the surroundings, because if that motor gets into a state that it gets too hot, can overheat, can start a fire. We don't want to burn up where we were. We're going to talk about the difference between the cross the line, which is motor connected directly to the supply line, and ramping. We're gonna talk about stopping, we're gonna talk about jogging and inching, and these are methods to move a motor with short jabs of power, when we're talking about jogging and inching. Speed control. Most common method is variable frequency control for alternating current voltage motors. And basically you control the voltage applied to the armature in fields of a direct current motor. So there's two different ways, whether we're talking about AC motors or DC motors. You're going to eventually get your hands on some variable frequency drives. And what that does for AC motors is allows you to control the voltage and the frequency to the motor to control its speed out there. And it's a highly precision way of controlling motors which aren't necessarily inherently precise on their own. And you'll see that as we get there.
Well, speaking of age, which we don't wanna disclose, as you said earlier, would that be the same situation when we used to have the racetracks? That you buy the slot cars, or the big slot
Oh.
cars, and you have the handle? the
You're
gun?
varying the voltage less on the frequency side, but yes,
So
you are varying.
You don't want to
Same thing with trains.
Okay.
You're varying the voltage.
Cool.
So less voltage, less movement, more voltage, more movement, just changes the speed.
Yeah, that's fine.
Controlling motor and circuit protection, we're gonna get into some of those. Surge protection, protects against spikes and surges. These things called mobs, we used to call them butter beans. They were kind of usually yellow or red, that are connected to a motor. They're connected across the coils. They absorb that spike or surge in some cases. And of course, safety. People around the equipment want to make sure they're safe as well. So there's that little mob. You can see kind of what it looks like. It's a metal oxide resistor. It eliminates voltage spikes. So if you've got a sudden spike, what happens is rather than the motor being exposed to that, this little device captures that spike and just kind of bleeds it off without harm to what you're getting there. And you can see right here just kind of what it does is it just keeps it from shooting way up and damaging the piece of equipment. If you look on a lot of motors, you'll see these little MOVs installed.
How does that work? In practical sense, how does that work?
I'm not sure of the theory behind it. I can try to find out, but basically it's something that regulates. It's like a valve more or less of something higher than the normal spike hits it. It just takes it and captures it and bleeds it through without any effect on the motor.
Would it be kind of something like a capacitor, maybe it's taking that, but then it's slowly instead of.
Yeah, it's similar. I don't know if it's the material inside of it that somehow dissipates it, or if it, like you say, it takes something that's this high and just kind of regulates it down. I'm not sure. I'll try and find out. All right, so again, that is just a very general overview. And most of this stuff you saw in here that we just went boom, 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 boom about, we're going to start drilling down chapter by chapter by chapter by chapter over here. And that's why I was wrong, there's not 66 chapters, there's 65 chapters.
Oh, okay.
Thank you.
Oh, gee,
Feel a lot better already, don't you?
Yeah.
So MOV is to protect the circuit or is to protect the motor?
Motor.
Well,
Break time tape keys are also called varistors, and basically they maintain their voltage rated. So if you had a 120 volt motor, you'd have a 120 volt rated varistor. And it goes into the theory. I'll be glad for you to read it. But basically they're little om-nom-nom components that gobble up anything above 120 volts and otherwise just sit there in parallel with the load and don't do anything unless there is a spike above the rating of the varistor itself.
they say how big they are, different sizes? Or?
They're usually, when you saw it in the picture before, they're usually, we call them butter beans in simple because they're typically about the size of a butter bean for lack of a better term. And so not much larger than your thumbnail. Typically probably about as thick as a dime, maybe a little thicker.
So that's basically actual size right
Well, well, you gotta remember on the screen, everything, I mean, there's a quarter in reality, but relatively speaking, that's the size. Where Bjork is sitting, that's about the right size, where you're sitting, it's pretty large.
No, the whole thing,
It's one,
one thing.
no, it's all together. That goes with it.
Yeah,
Everything you
there's
wanna
more
know about-
information than what you got right there.
Everything you ever want to know about baristers, but was afraid to ask. Is right there. Alright, we're gonna start talking about some symbology, because obviously, we've got to understand the symbols that are on a schematic to be able to understand what they represent. So we're gonna get into some of that as we go through. We're going to discuss the symbols, determine the difference among switches that are drawn normally open, normally closed, normally open, held closed, and normally closed, held open. And I had to look that up, and we'll probably have to revisit that again. I understood it when I put it in the slide, but we'll look at it. Draw standard NEMA control symbols, state rules that apply to schematic or ladder diagrams. If you go back to this diagram, anybody want to wager or guess this thing will focus? Press that elusive AF button. There we go. Why that might be called a ladder diagram?
You got rungs on?
Yeah, it looks like rungs going up progressively. And in fact, when you get into PLC, that will be called a rung. And in the ladder diagram, it really is too. But very, very much laid out like the rungs on a ladder. Therefore, ladder logic, ladder diagram, whatever the case might be.
It does act as a passenger, so. She said something about this open, it is like the passenger.
Interprets the logic of simple ladder diagrams, so we're going to see some of those. In fact, you already see them. And it's the written language. It is the language that you should be able to speak, at least in some way, once you finish. And really, once you got through that last simulator, because that really was a ladder diagram that we looked at, it just a much shorter ladder diagram. Symbols vary. We've already seen that what is that? A light. What is this?
Light bulb.
And what is
Lamp, specifically.
Light bulb.
Light bulb.
how did you know? A light bulb. So even something as simple as a light bulb has different symbology. So we kind of have to get used to having seen them all, but they're all fairly descriptive. Definitely the filament, the curved line, is pretty indicative. The first time I ever saw that other one, it looked like this. Was when I got into some stuff in this course. I'm not used to seeing that as a lamp, but that is neat. And there's some neat diagrams out there. I think maybe the index of this book even has some of the symbology. I will try to find during the next break some common symbols at least. Obviously, I can't give you every single symbol on a single sheet of paper, but at least some more common ones. Most standardized set in the U.S. is by NEMA, so there are some quote-unquote standards, but that doesn't mean everybody follows them. LEDs, one of the things we ran into. Everybody's familiar with an LED, right? Most of them that we're most accustomed to are round and kind of shaped like this when you look at them that way. When you look at them dead on like that, they're not really circular. There's usually wow, this whiteboard needs calibrating really, really badly. I'll try not to lift my pen. I've over-exaggerated it, but there's typically a flat side on an LED if you look at it. Industry standard is flat side is cathode. But sometimes flat side's anode. Yes. We found that out. So, nothing is 100% proof positive, and we had a bunch of them come in and we installed a few hundred of those backwards. Went back to got a different manufacturer that had the same side LED. Their manufacturer says we will mark the anode with flat side, while the rest of the world marches on to the cathode being marked. So, never assume. Push buttons. Obviously, switches and buttons are one of the most used symbols in schematics. They can be shown as normally open and normally closed. Most are momentary, and they contain both movable contacts and stationary contacts. You guys are already familiar with these. We've got a working model of them somewhere in the room over here. Normally open contact. The stationary contacts are the ones that stay fixed. You're pushing the top part of that switch into those stationary contacts, closing that switch, taking it from an open position to a closed. And then you have the inverse, whereas they normally reside connected to the two contacts, and when you push them, you're opening this normally closed switch. So, and here's an illustrated view of it. Obviously, when you push down on the spring, you're completing connection between this side and that side. Here, that connection is made until you push the button, and then you're breaking that connection. So that's the difference between normally open and normally closed. Now, there are some double-acting push buttons out there in the world. A good illustration is the one on the left right there. The top part of the switch is normally closed. The bottom part is normally open. So the switch is sitting there in the closed position is relative to the top contacts until the button is pressed. Then the top contacts open, the bottom contacts close. So they do make those types.
Emergency stop button.
No, normally emergency stop buttons will lock, but yeah, there are some that are made that way. And the dash line, as you see on the right, indicates that there's two set of contacts here. This one, you're taking that one contact, removing the closed, and bringing it down to the open to close it. Here you got two set of contacts, so the movement isn't as far or the distance is greater, such that when you press it, the top contact removes from the closed position, the bottom contact closes the open.
So pulled up top is open,
Yes.
push down is closed.
Also, could it be, it looks like on that last one on the far right, that you can mash it twice, you can mash it one time and the top one will go?
All
So
that
it's just-
show is, sometimes it's drawn as a single line,
Uh-huh,
and sometimes it shows a dash
I
line.
got you.
And that's
So
what
it'd
that's.
still be, the top becomes open and the bottom becomes closed?
That's right. And in
Okay.
fact, you've got a very similar one to this one at least in your schematic. That's it, even in its blurry state here.
Is that right, the local remote?
Yep.
Okay.
If you take a look, I don't know why this darn thing's quit focusing on me. But if you take a look, which one's normally closed, which one's normally open?
Is normally closed.
Right.
Three and four is normally open.
Right. And that one isn't quite as illustrative as the one in the picture because there's not the distance gap. But I imagine that has to do with the spacing of the drawing more than anything. But the difference here, is that a momentary switch? it's a toggle switch, right?
Yeah, that's a
So we can have this type in a toggle, which means you can set it one state or the other and let go and it'll remain in that state, or a momentary, which means when you let go on the interaction, it changes, it reverts back to its original state.
Could it be like with the push button? Couldn't it be that it locks in if you hit the push button too?
There could be some made like that, and just because of our mentality with momentaries or typically circular switches like that, you'll typically see this as kind of toggle switch that actuates like that. There could be some locking, and even those would not return back to their normal height. They would press in, and then you'd have to press them again to press them out. But I've never seen one that you would press it once and it would be in one state, but the button would pop back out to the same height distance, if that makes any sense, what you're saying. So, and I think that would be confusing if they did do that. So what you normally would see is you push it in, it holds in, then you push it in again and it pops back out. So, but I ain't seen everything. Who knows? Oh, look right back. One more time. There we go. Okay. So how many screws would be on a switch illustrated like any of these three here?
4.
4, that's right. One for your two for your normally closed, 2 for your normally open. And now you might see some could be jumpered. There might be some applications. Typically, you're going to see those be independent wires. But unless you're taking 120 volts from one side to one device of one kind, one device of the other, you might see the input side jumper together. And all I'm saying there is, like if this operated light 1 and this operated light 2, letting you know there was a different state and both of those lights were 120 volts. Crap, I've got to calibrate this board. I might have both of those tied together with the same voltage, but obviously this one would feed one light, this one would feed the other. So. Stacked push buttons. Connect multiple contact units together controlled by a single push button. Emergency stop buttons are some examples. We'll see one here in a second. You see here this actual stop button, this line, dotted line represents a mechanical connection. That is one piece of hardware with multiple contacts that can stop, interrupt all 3 of those motors
In the same time.
at the same time.
And if we see the dash between them, that's stackable.
Yeah, that illustrates a stacked 1 unit. So those lines illustrate one piece of hardware with multiple pieces. Push buttons are normally open, are both normally open and normally closed. And again, we see this combined way of doing it. Normally open contacts, normally closed contacts, and it represents a push-pull button. And that's why you have to pull it out to hit those top contacts. You have to push it in to hit those, have those other contacts. So it is a push-pull type operation. One of the things you'll find, and I don't know if Valmira will do it, but one of the things we used to do was, we were required to do daily, was check our e-stops on equipment. And
Stops, emergency stops?
yeah, we'll check and make sure it worked. We did it on a board handler one day and pushed the e-stop and the entire e-stop shoved inside of the piece of equipment. So that's one good reason.
But can you call them also double acting?
You can, depending on what it is that you're changing states. So yeah, it is double action. You're going from one state on one switch to the other state on the other.
And they also have 4 screws.
Yes. So here's a manual push-pull. And let's follow that circuit. Right now, what state is our motor in?
Off.
It's off.
It's off. Because we're not, providing a path. Actually, wait a minute.
You don't have a path.
No, you don't have.
You broke it in the switch
Yeah.
and broke it in the coil.
That's right, yeah, broke that. So what would I have to do to change that state?
Pull it out.
Pull it, that's right. Yep, so schematic using a push-pull as a start and stop control right there. All right. A run jog circuit using a push-pull. And, again, what happens is when you pull it to the run mode, it stays in the run mode, the motor actuates, and you're running. But the other direction is a momentary type push, and that allows you to jog the motor. As long as you hold your finger there, the motor is in jog mode. And as soon as you release your finger, it's no longer jogging.
That would actually be a three position.
That's
push
right.
pull.
Yeah, center off, out, run, push to jog. Exactly right. Lighted push buttons indicate a motor is running, stop, or tripped on an overload. So we can actually have intelligent push buttons that tell us the state of something out there in the field. So you may very well have a button that has a light indicating the state, good or bad, or whatever, on or off of a particular piece of equipment. All right, so normally open, normally closed, normally open, held closed, normally closed, held open. So diagrams show components in electrical sequence. Here's the important one. Always drawn to show components in their de-energized or off state. Any contact with the same label or number as a coil is controlled by that coil. When a coil energizes, all contacts controlled by it change position. So if we've got normally open and normally closed contacts on a coil, when the coil becomes energized, what happens to the normally open?
Close.
They close. What happens to normally closed? Open. Everything changes state. That's all that statement
So
says.
that one coil can control multiple contacts.
Exactly. So the other type of things we have are sensing devices, limit switches, float switches, pressure switches, flow switches, and temperature switches. What do you think a limit switch is for?
To control the limit of a constant set point.
Yeah, like when something's moving, left or right, up or down, it may have a limit this way, it may have a limit this way, it may have a limit this way, it may have a limit that way, whatever the case may be. As that motor moves, there's something attached to that motor that can hit that limit switch, and that lets that motor know you've reached your end point. That's a limit switch. There's usually a paddle of some type on it that will hit something attached to that motor and stop it. Otherwise, it's going to try to continue to drive. What about a float switch? What do you think a float switch does?
It's just in water.
Stops
when
the
the
fluid.
level gets to a
Takes-
certain point, it stops.
Yep. Look in this guy, if you still have it. If you go to page 3 of that, you'll see float switches of one type on this little cutaway diagram. And all it is these little devices float. They hit something that closes the contacts on them, and that contact changes state, and therefore you know we're at this point.
Well, wouldn't a float and a limit switch be synonymous in?
Yes, well, I mean, float obviously is floating in some
Yeah.
type of liquid, where a limit switch is just a hardwired fixed piece. So they have similarities, but the difference is obviously
One's electrical, one's.
float versus the float versus the limit. How about a flow switch?
In your heat and air conditioning systems, you have those a lot.
Right. It's something that the pressure of whatever moving through it pushes it, whether it's air pressure or gas pressure or whatever the case might be. How about temperature switches?
Temperature gets a certain point,
Yeah,
it cuts off.
water heaters.
It goes.
Water heater? What else is in your house?
Air. air,
Heat and air's got a temperature switch.
your oven,
Washing machine.
your oven.
Let's not talk about it.
Definitely a washer.
Maybe, ovens for sure, yeah. Otherwise, those cookies come out charcoal black or raw, depending on the case.
My oven.
Microwave.
A
Let's not
washing
talk
machine
about
would have a
ovens.
temperature?
Not that I can think of, now, there's probably some advanced ones out there, the normal ones won't, but I bet there's some that actually create their own hot water. Or maybe, I saw the other day, everybody's familiar with Uber and Airbnb, right? Uber is where you can call somebody in a car, and Airbnb is where you can rent out part of your house to perfect strangers. They're doing that now in certain countries with washing machines. They said people don't use their washers and dryers all the time, so you can now buy time at somebody's place and wash your clothes.
That's unreal.
Depends on what they're paying, but anyway. But here we have a normally closed limit switch. You see the little extra red piece on there. A normally closed open limit switch. And I know you're about to ask me, so let's look at this held open, held closed thing.
I asked that question the other day, what would be the purpose of it?
I can't remember I can't even remember what it was. I know I looked it up because I had never heard that terminology before, but you can see the difference at least in the state. But let's see if we can find out what that means, because I've spent 30 years here and I had never heard normally open, held closed, and normally closed, held open until this book, which obviously means it exists. And it's on page 13 through 15 and 19F. But I'm gonna be quite frank, I have no idea. All right, I'm gonna try to get through this in our brain, but on page 14
Lord willing.
of this book, the normally open, held, closed, and normally closed, held, open switches are shown just as they're shown up there. The movable contact of a normally open, held, closed switch is drawn below the stationary contact. So let's look at a normally open, held, closed. So it's normally open, but it's drawn in its de-energized state. So it's drawn in the closed state. Even though it's a normally open, held, closed switch. The fact that the movable contact, and this is a key word according to the book, is drawn below the stationary contact indicates that the switch is normally open. Since the movable contact is touching the stationary contact, however, a complete circuit does not exist because, a complete circuit does exist because something is holding the contact closed. A very good example of this type of switch is the low pressure switch found in many air conditioning circuits. The low pressure switch is being held closed by the refrigerant in the sealed system. If the refrigerant should leak out, the pressure would drop low enough to permit the contact to return to its normally open position. To me, it's a normally closed switch with another name.
Mm-hmm. Just drawn below the contact instead of above it.
So
Confused.
it's normally open because if it weren't for the fact that there was something holding it closed, such as the refrigerant, it would default to that state. But because the refrigerant is there holding it closed, it's a normally open switch, but it's closed. And remember, we think of normal as all conditions correct, but in this case, it's normally open if there's a failure of the pressure to hold it closed. So it's one of those things that my brain has trouble wrapping around because of the terminology. That is the essence of it. If there weren't conditions around to hold it closed, it will default back to its normally open state. So now we know. You might see it on the test just because I had to explain it.
You hate us that much?
Yeah.
It may be on the test anyway, I'm just not sure. Do you remember these? A float switch, what does that circle look like?
A circle.
A ball, or,
Like old timey corks
yeah.
that we used to use. Did you ever go fishing in New York with the old timey red and white corks? So it's just like that. Alright, we got a flow switch. What does that kind of look like? It's indicated. It looks like what?
Like a flag.
It's like a flag, also something else.
Like a sail.
Like a sail or a rudder on a ship. So if you think of a rudder being in water, and you think of water, something that flows, maybe that'll help you remember float versus float. Pressure switch.
Looks like a button pushed in.
Yeah, it does. It looks like something, but obviously that's
Looks like a
done.
plunger.
Yeah,
Looks like
it
a
does like a
plunger.
plunger.
Yeah. Alright, we'll go with plunger. And temperature switches
Think like a plumber.
have the little, and to me, that kind of reminds me of something that could heat up, cool, and expand, and contract, so
Kinda looks
kind
like
of
a
spring, yeah, or a coil, yeah. Proximity switches. Let's think about this. Float switches would be used in liquid, flow could be used in liquid or gas. And the difference in a float, what's the difference in a float and a flow? Where would we use a float?
A float is
Yeah.
kind of like
On that tank.
reservoir.
Like,
Yeah, we,
tank level.
we can know a level of a tank. What would we potentially use a flow switch for?
Like
Uh,
vertical.
Yeah.
And like a gas pipe.
You know something's moving, right? Not necessarily a volume of how much, but just the fact that something's happening. Pressure switches the same way. That could be a gas or a volume of air or whatever. Temperature switches. We already talked about those, right? Thermostats, various places. Prop switches are some of the neatest things out there. What's a proximity switch?
Like on the conveyors at the grocery store.
Ah, so if something gets close.
Right, you don't have to touch it. If anybody ever, I remember as a kid, the first place I saw a prop switch was downtown Dublin, Georgia, at Levitt and Tharp. They had the little beams of light, and when you crossed that beam of light, the door would open. So every time I rode by on my bike, I always kicked my leg out. Made the door open. But yeah, that's prop switches. Now they make them in different types. They make them capacitive switches that you can literally get your hand close to it, not quite touch it, and what happens is it completes the circuit. It knows that you're nearby, and that's really what Walmarts and all have is those types of proximity switches. Some are metallic. Some it actually takes a metal. I'm getting my
Inductive
I've been getting
sensor.
inductive versus
Inductive.
capacitive.
Capacitive. Yeah.
Yeah, inductive.
Capacitive will the sensors will actually anything really.
Yeah.
They'll respond to any metal, plastic, your hand.
Right.
The inductive switches, it's metal only.
Gotta be metal all the way.
So basically, that, like in my car, if I have my hand out the window and go to roll the window up, it will stop and it hits my arm and go back down.
Mine stops too, and I'm usually screaming at that point.
No, mine hit it and then go back down.
Yeah, I've seen those, and that's pretty neat.
Mine will break your arm.
Yeah. I don't have a screaming commercial too. Let's see, generally used to represent the core of a relay, coil of a relay, contactor, or motor starter. So circles are our outputs, they're the coil, they're the motors, and so forth and so on. The little EKG sign, for lack of a better term, used to represent a solenoid coil. But sometimes used to represent relay, contactor, or motor starters. Typically, you see this, I have seen this on some older schematics. Typically, you're gonna see that.
So that's an old one.
No, the solenoid is true to our schematic. Let's go back to our schematic. Yeah. So these are solenoids. These are relay coils. So this one is accurate to the book. But in some cases, this has been, in old times, been used for relay versus solenoid. But most everything I see, this is pretty much the norm, what that goes along with the book too. Iron core inductors versus air core, those are coils. We talked about the time contact symbols, normally open, normally closed, off delay. let's visit them. We talked about relays already, right? We talked about relays that have timers built into them. And some remain closed for an amount of time and then drop away. Some wait an amount of time and then close. So there's a difference. The on delay are represented here. Notice these are kind of pushing toward the contact, where these are falling away from the contact. So that's the difference. One delays and then pushes, one pushes then delays. So it just depends on, and if you look at your book, I think we'll get to the actual specifics of those later. Yeah, we'll be getting to them later on, but we'll talk about the difference between the timer on delay and the timer off delay. But it's the inverted arrows that make the difference on that symbology. You either got a symbol pointing downward or a symbol pointing upward. The on delay are pointing up, the off delay are pointing down. These you should know by heart now. Normally open and normally closed. That should be nothing at all new to you. These are some common selector switches: manual, off, and auto. Reposition. We either place it in manual, we place it in auto, or we place it in neither. Same thing in the second, same thing in the third. I was just showing the different positions. I'm sorry, I get what it's saying now. So 3 position switch: off, manual, or auto. So, and even though the machine may function the same way in manual as it does auto, at the very least here we see we get a different indicator based on whether it's in manual or auto. Alright, so you see a combination: start, stop, push button, pilot lamp, and handoff auto switch. We've got start, stop here, start, stop. We've got hand or auto, or basically manual or auto. We've got an indicator lamp that would indicate some state of our choosing there, typically an off with a red light. Selector switch with multiple poles. So we've got 1, 2, 3, 4 different sets of poles here. And as I turn this knob, these contacts change state across all 4 banks. But if I have this in position 1, I've literally got 4 different set of contacts that I can react to position 1 with. If I go to position 2, I've got another 4 set of contacts that I can do. And again, when we get the specifics on switches, well, here it is right here. You'll see it. So this just kind of shows that as we move, if we push that button in, everything shifts up and down. And as we dial here, this is a truth table. If it's set to A, contacts 1 and 2 are off. B, contacts are on. If it's set to 3 to 4, if it's set to A, 3 to 4 are closed. And if it's set to B, 3 to 4 off. So it's a truth table on what happens to this particular switch based on the setting. And again, we'll get to those. But if I wanted to know in the A position, if I've got it here, what contacts are closed, I can run down the A line, what contacts are closed when it's in the A position.
1 and 2 and 7.
1, 2, 7.
Oh, those are the ones.
It'd be 3 and 4, 5 and
Yeah.
6 would be closed.
Every word, yeah. 3 and 4, 5 and 6 are closed.
And 1 and 2
1,
and
2, and
7
7 and 8 are off. And oddly enough, either a mistake or something very unusual. I think this is supposed to be a 0. I think they blew it right there. I would almost suspect it would change opposite. I can't imagine how it would internally keep 1, 2, 5, 6, and 7, 8. But typically you see an inverse on truth tables. Maybe not. But I'll try to see if I can find a selector switch. That looks odd to me. All right, I said I'd try to look up some common symbology, so I'll do just that. So I'm going to give you another 20-minute break. We'll cover chapter 3, and we're probably done for today. We'll see you back at 20. Volts is L1, L2. And they typically do not provide low voltage release, do not contain electrical pull. And again, this is more informational, but this is a picture. 120 volt, 240 volt. Note the difference. We've got a high side and a neutral here for the 120. We have L1 and L2 for 240 volts here. And we got the overload heater built in here. We got a contact, same thing here. The only difference is what we're feeding.
So you don't have to have two overload heaters, but you do have to have the two contacts.
Right, because once you break one side, and both sides should be seeing the same amount of current, because it is a circuit, so obviously just like a standard series circuit, whatever we see here, we're also gonna see over here, so that's why.
Okay, I got a dumb question. Well, in being in that case, why would you need the double contact?
Just to release the high side, safety, if you're shutting it off, so you know that all power is removed from that motor.
Okay.
The
So you're
neutral
saying
is
that-
just like the ground, so it's safe to touch, but L2, if the motor's off, you don't wanna assume that contact is not hot.
Alright, okay.
So you're saying 240 is always gonna have at least two contacts?
240 watt now?
240 is gonna have at least the two contacts regardless?
Yeah,
At
Yeah.
least or just?
well, just two. There'll be a ground typically
Well,
too,
we're
yeah,
gonna think we're going with it, but 240.
but L1 and L2.
Okay.
Main advantage is mounting requires little space, can be mounted in a single gain switch conduit box or directly on the piece of equipment. We got a bandsaw down in the shop. It's mounted right there on the side. Open type can be mounted on the wall and covered with a single gain switch, available in different enclosures. We're gonna see some of those here, there they are. So, explosion proof, waterproof, and dust proof, so, working a body shop, you're gonna have those in the middle because they deal with some water sometimes, or at least some liquids. Of course, dust proof, that would be a perfect one for the carbon fiber, carbon dust place I was talking about. So they make them for different environments, bottom line.
Did they have those like that at the carbon place?
I don't recall seeing them, but I was mainly focused on the PLC side. You know how when you go in a plant for a particular reason, you tend to only notice certain things. And if I've been looking for switches, I'd have been paying more attention, but quite honest, I don't remember. Everything was virtually just kind of a dull shaded gray inside the building. There are some automatic operations. Sometimes we mind the manual starter with other sensing devices. Pilot device must be equipped with contacts that can handle the rated current. Line voltage devices have larger contacts. And again, we're going to see these things as we go along. And we've got a manual starter here, but that's not the only condition that has to be satisfied to start that blower. There has to be a certain temperature. So even if we manually start it, if that temperature condition is not met, the blower is not going to come on until that condition is met. So we can manually close that switch, but if the temperature switch is not acting as it should, we still won't have a blower until that is. So what are these contacts right here? Overload. What are they designed to do? What are they for? What is their purpose in life?
Prevent overcurrent.
Check that motor.
Check that motor. That's exactly right. Good.
What is the figure 3.8, what application would that be used for?
Temperature measurement. That's this right
Oh,
here.
just to measure it?
Yeah.
Okay.
So basically, if it's not seeing the proper temperature and it would be wired in line, this device would be attached to something, but the contacts are, which you can't see on here, would be part of this circuit that would be in series. So if this guy is not closing those contacts based on the temperature reading, then blower's not gonna come on. All right. The pump here can be controlled either manually or automatically. And you look, if we put it in the manual mode, then we're going to supply power to the pump manually, and no other part of the control circuit is going to come into play. But if we switch it to auto, then the float switch now becomes what activates that circuit. So if for some reason we wanna operate that circuit manually, even though the float switch hasn't closed, to make it, we can switch it to the manual mode, override the float switch portion, and go ahead and turn on that pump. And there might be a reason we may have it designed to pump out if there's 3 inches of water or something in there, but maybe we're about to go in there and work, and we want it the bare minimum, so we go ahead and pump out what's there. I'm just using it as an example. Obviously, there's other conditions and reasons. Some manual push button starters, besides the fractional, they're integral. 2 contact models are intended to control single phase motors operating on 240 volts or direct current, and 3-phase contacts are intended to control 3-phase motors. Do y'all remember what the phases look like? Well, we've got our straight line. We've got 240 volts. Looks like this right here. So obviously we get the 240 by the peak phase of each one, which will be, we're talking about RMS when we're talking 240. When we talk peak or peak, we're talking about a higher value. And then 3-phase is very similar. So notice we always have a 0 point at 240. At some point where both of them are meeting, but with 3-phase, they're always offset. You got 1 phase doing this. 1 phase doing
They're
this.
always offsetting by 120, right?
Right. 1 phase doing this. So no matter where I draw a vertical line, if I continue this on through, I've always got greater than 0 volts. I would have to do this repeatedly to fully illustrate that point, but there is never a 0 point, so that makes 3-phase more efficient and stronger simply because we're never cycling to a 0 point at any time. If overloads trip, a mechanical mechanism will open the load contacts and disconnect the motor from the line. And after they cool, it's got to be reset. So we don't want this thing continually, if we're away from it, heating up, stopping, cooling down, starting, heating up, stopping, cooling down, starting. Once it heats up, stops, we're going to have to do some kind of manual interaction. And the reason for that, if something's jammed in there and the motor's not turning, obviously it's going to heat those heater coils, the motor's going to stop. But if we don't correct that problem, as soon as those coils cool, it's going to repeat that same cycle, and even that could have some detrimental effects on the motor itself. So we have to stop it and restart it. All right, there's a 3-pole manual starter. So what happens is, again, what are these right here?
Overload.
Overloads, relays, and these are 3 contacts right here that close simultaneously to start that motor. Because now we're talking about 3-phase, and Mark was in here talking about things single phasing. We want all 3 phases to open and close at the same time. So these 3 contacts will open and close simultaneously to deal with providing power to
Do
this
you
motor.
ever have a 3-phase that can do it at different times? Can you do that?
I mean, you could, and that's where he was talking about the motor, we get into single phase motors, and heat begins to build up, and like you said, you'll hear them too. So at that point, hopefully your overload contacts will open, or
Yeah,
if not,
sure.
operator will intervene.
I looked out on the sawmill, one of the motors they had on the conveyor system holding some of the boards up was single phase at the time because of a nasty contact. There is no mistaking it. It's single phase. That's a sound you won't forget.
And it's just like the router I talked about a while ago. If an operator's nearby, you can hear a distinctive difference between the normal paths that it should travel versus, you'll hear a distinctive difference in the sound that motor's making. But if you're not nearby, you'll never know. Or if there's other noise higher than motor noise itself. Low voltage release and low voltage protection. What this does is both employ a solenoid that senses voltage. If we see a drop in voltage, it disconnects. So what that means is, if for some reason we bind, we have something happen, the power is going to shut off, and the solenoid is going to drop out and prevent that power from starting back up. It's basically a trip. It's akin to, but not exactly the same as a ground fault interrupt. If you ever have a ground fault interrupt, if I'm in the bathtub with a toaster, I don't want that thing recycling itself. I want to get that toaster out of the bathtub before, why I'd have a toaster in the bathtub, I don't know, that's how they used to kill themselves in Hollywood.
Yeah.
So,
They would just want some breakfast.
so, anyway, but yeah, it does have to be manually reset here. And you can see that solenoid, and all that's doing is, if power ever gets interrupted, it kicks out and keeps this thing from reactivating without a manual reset. And I'll show you, I think there's a picture here.
Why is it's connected just to 2 lines, not all 3 of them?
Once those 2 lines are out, that's a good question.
Because it will change direction. Oh no, sorry.
I'll find out. I'll do my best. That is a very good question. Because yeah, it should kick out all 3. Or maybe the fact the other 2 kick out, maybe there's some logic that probably what you're doing in your ladder diagram is monitoring the solenoid. If the solenoid drops out, then it disconnects power to all 3, would be my guess. So it gets its power from 2 of those, but it has the ability to kill power to all 3. So I think you're just going cross-leg to power that solenoid, but then the actual solenoid is controlling all 3 legs. That's my story for now until I find something good. So, the first question is, when a motor trips out, what's wrong? Was it a bind? Was it bad bearings? What's one of the easy ways to tell if bearings are bad in the motor? Listen, what else? If it's off,
Try to turn.
try to turn it, try to wiggle the shaft. If you see the shaft wiggling up and down, you probably got some bad bearing. Could be some shorted windings. These windings that are inside a motor, if you've ever pulled a motor apart, you'll see the shaft, you'll see all these different windings that surround it. Occasionally they'll short out. They're coated wire, that's all they are. Some kind of enameled wire. And either things can get down in them and damage that coating, or maybe the coating process didn't take place well enough, and after some time we short through. I mean, if it's just a little bit, in other words, if you got all these scores of winding and maybe 1 inch of that winding gets shorted out, probably not a big deal. But if it's from one side of that winding to the other, and in essence you've taken out virtually all the winding, you're going to get an overload. So it all kind of depends. But find the motor full load current. So the first thing is, what's it supposed to pull? You know, if I just climb an ammeter on it and go 30 amps, okay. 30 amps relative to what? 25 amps or 5 amps, you know. So you got to understand what the running current should be versus what you're actually measuring. And there's an example. We're going to measure on a single leg of any of this. And if we, especially on line and neutral, because they're offset, if we go across more than 1 leg, we cancel out the magnetic field and we don't read anything. So we've got to read just a single phase. I can't take a cord like this and use a clamp-on meter, because I'm going to get an offset. They actually make a little device you can plug that into that can let you measure just 1 phase of that, or 1 line of that, with your clamp-on ammeter. And again, we'll get to see that when we get to play with motors here. Was it a thermal overload? Loose connections. Loose connections can heat up and cause you to draw more current. Our lawnmower had an interesting problem this weekend. When I turned it off, it was going, it sounded like the solenoid was firing for the starter, but the starter wasn't turning. And I'm like, that's odd. Well, I disconnected the battery, or I was trying to disconnect the battery. I didn't want to just kill the battery and everything else. And as I started disconnecting the battery, it lost power for a second. But then as soon as the wire touched again, it started going. I'm like, so thankfully it's got the seat sensors in it, so even though it was turning over, it wasn't cranking. What I found out, and I'm gonna have to get a new switch for it, is you can bang up there near the control panel and quit doing that. So I got a switch that's doing it. But if you've ever messed with a battery cable, and this is what reminded me of that loose connection, as it's arcing, as I was trying to pull that wire fully off that cable and undo those screws, that thing was getting hotter and hotter from all that arcing. And after a little bit, I just had to, if it kills the battery, it kills the battery. But finally, I was able to bang enough on that switch that it quit trying to do that.
You didn't have an inline fuse to pull, you didn't take it off?
Well, I mean, it was operating as it should. It thought the switch was turned, but yeah, no. I've got a fuse to the actual starter, to the solenoid of the starter, but not to the starter. So anyway, after I burned my hands with it 3 times, I give up trying to take the battery. If you've got some surrounding air temperature, cool the motor down. It should have vented cover plates, but if you want to try to troubleshoot it and try to get back, you can cool down that thermal overload and get it back going for the purpose of troubleshooting. That shouldn't be a long-term fix. You don't want to override the overload just by using a fan.
You don't wanna keep just a fan on it.
Right. So, what questions do we have?
Back to that solenoid crossing 2 lines.
Yeah.
Can you run that by me one more time?
What I
Maybe
think is
somebody's not
happening
clicking.
is, inside of the ladder logic, we're monitoring the status of that
Right.
solenoid to provide motor contact closure to the motor. So if that solenoid ever opens, you've got to, as long as this solenoid is closed, send power to the motor. But if the solenoid opens up and it's a manual reset,
Okay.
then we no longer send power. It's a normally closed type protection device that opens. So we say provide motor power to the motor as long as this guy's closed, but if he ever opens, don't provide power to the motor until he recloses.
Okay.
So it would require you to reset that logic there.
So that will work similar like to a GFI then.
It's similar related. It's not for the same reason. It's tripped
But
because of some other reason, whereas a GFCI, all it does is it monitors the current on the 2 legs, and if one leg is higher than the other, if there's a mismatch between the current, then it trips out. But this is because of a power loss, basically.
Where would you place the MOV for search?
Where's your place to across the load?
Sorry?
Across the load. The MOV, the MOV,
Yep.
yeah, across the load. It's what they call a shunt, so that means parallel.
Mm-hmm.
So it'd be across the leads of the motor. In fact, I went down trying to find the motor. Most of your devices in VCRs and all have a little knob across the motor if you're ever taking a VCR across. But I'll go back to that slide. Actually, we'll Google. Remember, mod is also called a resistor. Well, I thought for sure we'd have to fix it.
That's what it printed out earlier, but I don't have the front page.
No, it's right on the back of the little
There's
AC.
Yeah,
one
but-
right there, isn't it?
Where?
Up above where the.
Right there?
Is that it?
That's one that's blown out. Now, that's part of the circuit. Now, it can be in the circuit, but a lot of times they're actually physically
Yeah.
across the motor.
All goes together.
They work electrically, I'll show you. Apparently, I can't find one.
But when you go to the solenoid, so the solenoid is placed before the
What?
thermal overloads.
Right.
And where the MOV will go, before or after?
Well, the MOB is a different component for a different reason. The MOB is for spikes. It would go right across the load itself. So here's your motor. here's the two contacts for, L1 and neutral. Oftentimes, you'll see that little MOV attached straight to the motor.
Oh, just like that, okay.
Yeah.
Okay.
But if not, these wires may go over to the circuit board, and then you may have the MOV on the circuit board, but it's still the same as if it were physically attached across the back of the motor.
If you read that stuff that I gave you to help you understand better,
Where'd you get that?
Lee printed it out earlier.
But you would get down to what you're talking about, Callie, is basically, you know, you'd have something that would look like if the switch is closed, and if the solenoid is closed, then the motor. But if this ever opens due to some condition, I'm gonna have to manually reset it before this will become true again to turn my motor on.
Like the contactor.
Right,
Just
exactly.
make trip out, okay, I got you. I just,
So it's just a safety feature. Anything else? I will try to find you some schematic symbols before tomorrow. I'll make that my before lunch project. And we'll see you tomorrow.